Students, this is another video that I have prepared it from the first exercise 1A from the chapter Trigonometric ratio. And in this video I have taken 3 questions from that exercise, that is question number 14, question number 24 and question number 20C. In the 14th question it is given, if 5 cos theta minus 4 is equal to 0, then find the value of sin theta, tan theta and sec theta plus cosec theta. So from the equation, first we are going to figure out the value of cos theta, and it can be done like this: 5 cos theta minus 4 is equal to 0. On bringing this minus 4 on the other side by transposing, the value can be written as 4 plus 4, and the equation will be 5 cos theta is equal to 4. Now in order to find out the value of cos theta, we are going to cross multiply and we write cos theta is equal to 4 by 5. Now as we all know that cos theta is a ratio that is being formed between base and hypotenuse. That means the value given in the numerator is the base and the value given in the denominator, that is the hypotenuse. And again, by using Pythagoras theorem, we can figure out the value of perpendicular. If we substitute the value of b as 4 in this equation and the value of hypotenuse as 5 in this equation, we can easily figure it out, the value of perpendicular as 3, and that I have already shown it to you in the previous video. Now once you have got the value of perpendicular as 3, then the first part, that is sin theta, which we all know that it is a ratio between perpendicular and hypotenuse. In place of perpendicular I'll write 3 and in place of hypotenuse I'll write 5. So the answer will be 3 by 5. Similarly, tan theta is perpendicular upon base, and in place of perpendicular I'll write 3 and in place of base I'll write 4. Similarly, the sum of these two, that is sec theta and cosec theta, in place of sec theta I'll write hypotenuse upon base, which is actually a reciprocal of cos theta, and in place of cosec theta I'll write hypotenuse upon perpendicular, which is actually a reciprocal of sin theta. So in place of hypotenuse I'll write 5, as we all know from here. In place of base I'll write 4, which we also know. So the value will be 5 by 4 for sec theta, and for cosec theta again hypotenuse is 5 and the perpendicular, the value that we have taken out earlier by Pythagoras theorem, that is 3. So cosec theta is 5 by 3. Now simply by adding the two fractions that we generally do, we'll take the LCM 12, the values will be 15 plus 20 and the answer will be 35 by 12. In this way we can get the answer for these 3 parts. Similarly, if you see the question number 24, which is given, if sec theta minus tan theta upon sec theta plus tan theta is equal to 1 upon 4, then we have to find out the value of sin theta. So in this particular question, what we are going to do, we are going to cross multiply. On cross multiplying 4 with sec theta minus tan theta, as I've written over here, and on multiplying 1 with sec theta plus tan theta, we'll be getting the value as 4 into sec theta, 4 sec theta, 4 into minus tan theta, that is minus 4 tan theta, then 1 into anything, that is going to give us the same value, that is sec theta plus tan theta. And because sec theta and sec theta are like terms, tan theta and tan theta are like terms, so I'm going to bring this sec theta on the other side, and it can be written as 4 sec theta minus sec theta, and tan theta on the other side, which can be written as tan theta, and on bringing this minus 4 tan theta on the other side, that can be plus 4 tan theta. Now on solving these two like terms and these two like terms, we'll be getting 3 sec theta, and this can be 1 tan theta plus 4 tan theta, that is 5 tan theta. Again by cross multiplying and bringing tan theta below sec theta and 3 below 5, the proportion that is formed is sec theta upon tan theta is equal to 5 upon 3. Now after that, what we are going to do, sec theta value is actually hypotenuse upon base and tan theta is perpendicular upon base, equal to 5 upon 3. Now if you see, both the fractions have got denominator value as base only, so these two denominators can be cancelled, and now on the left hand side of the equation we are left with hypotenuse upon perpendicular, which is equal to 5 upon 3. On reciprocating on both the side, it will become perpendicular upon hypotenuse, and this ratio will become 3 by 5. And as we all know that the ratio between perpendicular and hypotenuse is sin theta, so the value of sin theta will be 3 by 5, and this is the answer. Similarly, in the other question, that is question number 20 that I've done over here, in this particular question it is given, if 2 cos theta is equal to root 3, then we have to prove that 3 sin theta minus 4 sin cube theta is equal to 1. So again, from this particular equation, 2 cos theta is equal to root 3. I'm going to find out the value of cos theta by bringing this 2 below it by cross multiplication. So cos theta value will come out to be root 3 by 2. And as we all know that cos theta is base upon hypotenuse, that means the value in the numerator will be considered as the base and the value at the denominator, that will be considered as the hypotenuse. And again, by Pythagoras theorem, as you know, the equation is p square plus b square is equal to h square. You are going to substitute the values. So in place of p square, I'm writing p square only. In place of b, I'll write root 3 square, and in place of h, I'm going to write 2 square. As you know, root 3 square will give us 3, 2 square will give us 4. These two are like terms. On bringing them together on one side, p square will be 4 minus 3, that is p square is equal to 1, and therefore p will be 1. So if we substitute the value of different trigonometric ratios given in this particular equation, let's see, are we getting 1 or not? So this is 3 sine theta minus 4 sine cube theta is equal to 1. This is what we have to prove. So solving the left hand side first, 3 into sine theta. Now we know sine theta is actually perpendicular upon hypotenuse, and the value perpendicular we have taken out as 1. So I'll write 1 over here upon hypotenuse, which we already know from the given equation, that is 2. So that will be 3 into 1 upon 2 minus 4 into sine cube theta. Now remember, this cube is placed on the ratio, not on the angle. That means once you have taken out the value of this ratio, sine theta, you are going to cube it up. So sine theta just now you have taken out as 1 by 2. So I'm going to write 1 by 2 and I'm going to place the power 3 over it. Now let's solve it. 3 into half will be 3 by 2. 1 by 2 cube is going to give us 1 by 8, and into 4 on cancellation you will be getting 1 over here and 2 over here. So finally we are left with 3 by 2 minus half, 1 by 2. On subtracting these two fractions, we will be getting 2 as the LCM. 3 minus 1 is equal to 2 upon 2, that is equal to 1, and this is equal to the right hand side value, which we have to prove, that is equal to 1. In this way we are going to solve the questions.